And now we're working again. Where did I leave off calling on people? Maybe Chris, you guys? Okay. Ah, good. Bethany, had I called on you? Yet? No. Okay, so you. All right. So, hydrogen causes a small explosion in the presence of a flaming splint. You tested the gas you think is hydrogen. Did you hear a pop?
For mine, no, but for the others, yes.
Okay, so you can write whatever answer you've got. But it would be good to note that you did at least hear a pop from some people's. So make a note there. You heard a pop? Yes. And Lily, because there are two hydrogen atoms, and if you look at the picture, those are white. For every how many oxygen atoms?
One oxygen atom.
One oxygen atom, which are red, in the water, more what kind of gas is produced? Hydrogen. So you guys have black and white copies of this sheet, but we'll maybe draw kind of a color representation of it on the board. I can't aim the camera, that's so sad. Okay. Oh, that'll do. Okay, so when you look at the decomposition of water, I'm going to do oxygen here in purple. What really turns out to happen is that two water molecules have to decompose to kind of end up completing the reaction. So hydrogens are these little blue guys and oxygens are the big purple guys. And when you break their little chemical bonds apart, nothing else is blowing up, right? Then you end up with, well, actually it's kind of the other way. So you end up with two hydrogens, like this, because remember hydrogen has just two molecules bonded together. So, and then you end up with one oxygen molecule. Two oxygen molecules together. So you see hydrogens go here, hydrogens go here, and then these two oxygens come together to go here. So you end up with, maybe a different color, two waters break down into two hydrogen molecules and one oxygen molecule, which tells us why Max is like, why did you have only one oxygen over here, but you ended up with two over here? But this explains it, that it takes two water molecules to break down into two hydrogens and one oxygen. So that's really what happens. So you have to, it's called balancing the equation. You have to break down two water molecules to get two hydrogens for one oxygen. That's why we make more hydrogen gas in this experiment, because you have twice as much hydrogen per water molecule as oxygen. And gases just exist regardless of the size of the molecules. They take up the same space. So twice as much hydrogen gas takes up twice the space as half as much oxygen gas. Does that make any sense at all? Yeah. Okay, good. All right, so we did, of course, have some sources of error in this experiment. So maybe some things that you observed during the experiment that didn't necessarily contribute to it going perfectly. So you three, can you think of anything that you observed that might have caused problems with the experiment?
Air got into it. And
that's a big one. Yes, when we flipped them over, sometimes there were little bubbles that got in that shouldn't have been there, and that is a big source of error. So regular old air was trapped in little bubbles in the test tube at the beginning of the experiment. So that affected the amount of gas that you could see being made and the ability of the gas to pop when it was exploded if it was hydrogen. When we flipped the test tube into the beaker, some air got in and you had a little air bubble. So for the source of error, you could say air bubbles got trapped in the test tube before we started, or you wouldn't want to say we. Air bubbles got trapped in the test tube before electrolysis began.
You could solve that technically if and find a way to that you could get a smaller test tube in width. That way your finger could fit more easily over it, and that could help solve the problem.
That could. But then you wouldn't be able to hold as much gas, and you wouldn't have the fun popping at the end.
Well, with their experiment, the test tube was so big that they couldn't really fit their finger over it and keep air from getting there.
I should give guys with bigger hands the bigger test tubes, and our little hands don't cover the opening well. That is true. Oxygen, that's not really something that we worry about in this lab because we corrected for that. What else did you see going on in the test tubes that might have caused some error in the amount of gas that was made? And I know your textbook talks about this. What do you see? Look at that beaker and tell me what you see that might have caused error. Okay, so we had some corrosion, some reaction going on that wasn't just the decomposition of water, breaking down water into hydrogen and oxygen. Something else was clearly going on in that beaker that turned blue right there. Can't see it in the camera. Yeah, there's still a battery in there. Their wires weren't working, so we just dunked the battery and collected the gas right from the terminal. No, because we didn't actually perform the experiment with the bad wire. We just dunked the battery. Their procedure is just going to be different. But they are still collecting plenty of gas, yeah. So maybe somebody who didn't get... whose gas didn't explode? Right? You guys, yeah. Who would like to attempt to hold a match or a test tube full of hydrogen?
Match.
Max, you and Bethany can do it. She wants to hold the match, so you're in the line of fire. It's your thumb that's right. I'll give you guys goggles and you can come up here and do it in a second. So another source of error is that we observe reactions occurring that weren't part of the reaction we were trying to perform. So you can write that in there in your discussion. And I'll write it on the board here just to make sure you have time to do it. And I'll make sure I don't use the word we or I in my discussion like we do when we talk about it out loud. So I might say something like that. If you say something that's slightly different, that's not a problem. And then you can see the big purple oxygens and the small blue hydrogens. It takes 2 water molecules to form hydrogens and 1 oxygen molecule. And that is on your paper already. So now we need to write a conclusion. So when you write a conclusion, it's really important to refer back to your objective. Always go back to your objective when you're writing your conclusion and reread it. So our objective today was to break down water, which is a compound, into hydrogen and oxygen gases, which are elements. So, Duchesne.
I have a question.
Yes.
We added baking soda to this, so where is the baking soda going?
The baking soda, hypothetically, should not participate in the chemical reaction. It should only allow the electricity to be conducted through the water.
Okay, so it's still in the water that's not in it.
Yes.
Okay.
Where did you pour the baking soda? Did you pour it into the big water
I
jug?
poured it into the gallon jug. The one I threw away, this gallon, I just used extra water from. Yes.
Would salt possibly have worked better than baking soda?
Salt will work differently, and it will work. Not necessarily better. Magnesium sulfate, which is sold under Epsom salts, works really well too, but I didn't know where mine was at the moment, so we went for baking soda. Really, it all works fine, especially for the purpose we have here. We're not actually measuring quantities or anything. So, if you look at your objective and it says to decompose water into its elements, then what should your conclusion be? Did you do it? So what would you write for a conclusion? Perfect. Water molecules were decomposed into their elements or into hydrogen and oxygen. Water molecules were decomposed into hydrogen and oxygen. That works perfectly. So when you get stuck at the end and you're looking at your conclusion thinking what to write, go back to your objective and just answer. What was your objective? Write the answer. If your objective was to measure the mass of something, then your conclusion is going to be the mass was 4 grams, or whatever the mass was. It's just the answer to the question. So the water molecules were decomposed into hydrogen and oxygen is a perfect conclusion. All right, so what else do we need to talk about today besides the lab? Okay, there are a few more details to cover in class today, and I hope I still have some time. Okay, I want to... I don't know if I can even get close enough here. Is that test tube running out of space? Okay.
It's going down really. I mean, you can watch it go down, but it's past the water.
So a few other things I want to tell you about today, if you want to make notes or something. Chemical formulas and how to count molecules and atoms. So you had a few on your own about this week. So I'm going to put up a couple here of chemical formulas and see if you can tell me how many atoms of each type are present here. Oh, you don't know how to do that yet. Hold on. I don't think you know how to do that yet. No, you don't. Okay, so here are a couple of chemical formulas. Let's see. How many of each type of atom are present? So Meredith, if you look at this is sulfuric acid.